Hello, everyone. Welcome to the lecture on the introduction to probability. We are going to cover the fundamental concepts of probability. So we're going to explore what probability is, its historical context, various applications, and also we'll look at key principles and rules that govern this area. Introduction. So probability is a measure of the likelihood that an event will occur. So it quantifies uncertainty and allows us to make informed decisions based on the likelihood of different outcomes. Historically, probability originated from the study of gambling and games of chance, but it has since evolved into a crucial component of mathematics and statistics. So these days, probability is used in a wide range of fields, including finance, engineering, science, medicine, and even in our daily lives in some context by helping us navigate uncertainty with greater confidence. Basic concepts. So let's start with some basic concepts in probability. Let's go over an experiment first. An experiment is a process that leads to the occurrence of one and only one of several possible observations. So an outcome is the result of a single trial of an experiment, and the sample space, usually denoted by S, is the set of all possible outcomes of an experiment. An event is often denoted by E, is a subset of the sample space. So it can consist of one outcome or multiple outcomes. Examples of basic concepts. In order to illustrate these concepts, rolling a die would be the one of the easiest ones to cover. So for example of rolling a die, the sample space S consists of all possible outcomes, 1, 2, 3, 4, 5, 6. And if we are interested in the event of rolling an even number, the event E would consist of the outcome 2, 4, 6. And this simple example helps us understand how sample spaces and events are defined in probability. Types of events. So events in probability can be classified into different types. First, a simple event is an event with a single outcome. For example, rolling a 3 on a die. A compound event consists of more than one outcome, like rolling an odd number, which includes the outcomes 1, 3, 5. And mutually exclusive events are events that cannot occur simultaneously. So to give you an example, rolling a 2 and rolling a 5 are mutually exclusive because you cannot roll 2 and 5 at the same time. Independent events are events where the occurrence of one event does not affect the occurrence of another. So an example would be rolling a die and flipping a coin. the outcome of one does not influence the other. Probability rules. There are a number of ways to define and calculate probability, and the classical definition is used when all outcomes in the sample space are equally likely. According to this definition, the probability of an event E is the number of outcomes in E divided by the total number of outcomes in the sample space S. There is another approach. Another approach is the axiomatic definition. It is based on Kolmogorov's three axioms, and it states that the probability of any event is between 0 and 1. The probability of the entire sample space is 1. For mutually exclusive events, the probability of their union is the sum of their probabilities. Conditional probability and independence. So conditional probability is the probability of event A occurring given that event B has already occurred. So it is calculated using the formula shown here. And the condition that we have to meet is that probability of B occurring has to be greater than 0. And another one, events A and B are considered independent if the occurrence of one does not affect the probability of the other. Mathematically, A and B are independent if probability of A and B is equal to probability of A times probability of B. So understanding these is really important when you want to analyze scenarios where events influence each other or occur independently. Bayes' theorem. So Bayes' theorem is a really powerful tool in probability that allows us to update our beliefs about the likelihood of an event based on new information. The theorem is expressed as probability B given A times probability A divided by probability B. So what this is doing is this formula is helping us calculate the probability of event A occurring given that event B has occurred by taking into account the likelihood of B given A and the initial probability of A and the overall probability of B. So Bayes' theorem is widely used in fields such as machine learning, medical diagnosis, and decision-making processes. Random variables and probability distribution. A random variable is a function that assigns a real number to each outcome in the sample space. There are two types of random variables, discrete and continuous. Discrete random variables take on a countable number of distinct values. And for these variables, we use the probability mass function to describe the probability of each value. Continuous random variables, on the other hand, take on an infinite number of possible values within a given range. And for continuous random variables, we use the probability density function to describe the probability of the variable falling within a particular range. So understanding random variables and their distributions is important if you want to analyze and interpret data in probability and statistics. Expected value. So the expected value of a random variable is essentially its mean or average value. For discrete random variables, the expected value is often denoted as with E of x is calculated by summing the product of each value x and its corresponding probability of x. So hence we see this formula. For continuous random variables, the expected value is found by integrating the product of the variable x and its probability density function over all possible values. And the formula is shown here. And the expected value provides a measure of the central tendency of the distribution of the random variables. Common probability distributions. So if we were to look at some common probability distribution, first one would be the binomial distribution. The binomial distribution is a discrete distribution that describes the number of successes in a fixed number of independent Bernoulli trials, where each trial has two possible outcomes, success or failure. And the normal distribution is also known as the Gaussian distribution, is a continuous distribution characterized by its bell-shaped curve. It is defined by its mean and standard deviation and is widely used in statistics due to the central limit theorem. And lastly, the Poisson distribution is another discrete distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space. And this is particularly useful if you want to model rare events or events occurring at a constant average rate. Law of large numbers. The law of large numbers is a fundamental theorem in probability that states that as the number of trials of a random experiment increases, the sample mean will converge to the expected value. So this theorem implies that with a large enough number of trials, we can predict the long-term behavior of a random variable with greater accuracy. The law of large numbers underpins many practical applications of probability, thereby ensuring that repeated experiments yield reliable and predictable results over time. Central limit theorem. The central limit theorem is another important theorem in probability theory. It basically states that the distribution of the sample mean of a sufficiently large number of independent and identically distributed random variables will approach a normal distribution regardless of the original distribution of the population. And this theorem is important because it allows us to make inferences about population parameters based on sample statistics, and it forms the basis for many statistical methods, including hypothesis testing and confidence intervals. Conclusion, so we have looked at the fundamental concepts of probability, including definitions, basic rules, and common distribution. We're going to look at each concept more in detail in subsequent lectures, but know that probability helps us quantify and manage uncertainty, so making it a vital tool in various fields. So understanding probability enables us to analyze data and predict outcomes. So I definitely encourage you looking into probability more and explore its applications in greater detail. Thank you everyone for listening.